Okay, let's get nitty gritty. Let's talk about the crap no one understands and nobody on any photography board will be discussing, because unless you're a technician working for Nikon, Canon, or Pentax, or Fujinon, or Zeiss, or Leica, nobody knows this crap, and you don't read about it in photography magazines. And I got pissed off recently when Yannick, who writes a photo blog, and I've been pissed in general about this fact, but you know, you can't blame people for ignorance. One of the first steps of wisdom is to say that you don't know. You don't necessarily want to know, but you know, the first step of wisdom is to say, I don't know. Now, to make crap up or say that something's not true when you have no idea and you have your head up your ass is what pisses me off. On this sort of stuff, that actually makes me angry. Now, on places like some of these photography boards, which I won't name because they all suck ass, and they're full of a bunch of knuckle-dragging, mental midget, intellectual inferiors, you know, people think that, well, a lens outside of the motors and the crap that it's just glass. You know, it's ED glass, aspherical elements, doublets, flint elements, achromatic doublets, and it is all about MTF and you know, micro contrast. But none of these people know anything about electricity, how a lens is designed. Now, when we're talking about visible light, which of course in photography that's all we're really interested in, unless you got a full spectrum camera or an infrared converted camera, in which case it's slightly useful. Especially if you take the infrared pass filter off of your camera, which you can buy those off of eBay. And they are tons of fun too, by the way. Nothing like shooting camera and exposing for ultraviolet and 590 nanometers through 750 whatever nanometers of infrared light. That stuff is cool to me. I mean, it makes really friggin' neat pictures. And you ought to get into infrared photography. All it requires is one decent lens. Not all lenses are capable of infrared photography, and an infrared filter. The easiest ones are like the 720 nanometers. But anyway, I was talking before that this is an irrefutable fact, and you're not going to read this in any photo blog or magazine or any of these damn books on photography, and it is effing refutable. Okay? That is that all lenses are designed, ultimately, as electrical circuits for the perfect transmission of glass based upon the spectral specs that are desired by the manufacturer. Now, the Sigma Fart lenses have their own flavor to them. People that know what they look like, that looks like a Sigma Art lens. Some of the Zeiss lenses, the really high element Zeiss lenses, they kind of look like the 35mm f1.4. They look like that, except they have much, much better micro contrast, and of course are built far, far, far superior. And by the way, they cost the same amount of money, which blows my mind why anybody would buy a Sigma Fart lens. So you got $1,000 on a Sigma Fart here, you got $1,000 on a Zeiss Distagon over here. Well, holy crap, this one's made 10 times better. It's worth a lot more money. It is built a lot better. It's got far better micro contrast, far higher IQ. Geez, for $1,000, which the hell one will I buy? God, what a tough choice. That's what blows my mind that people buy that. Because it's like, why buy a Zeiss for God's sakes? You know, well, it's a manual focus lens, and you know, every time I open up a photography magazine, I see these Sigma ads. Yeah, Sigma's got advertising everywhere. Which goes to show you that you can sell junk to a lot of people at a high price if you do enough advertising. That's something that pisses me off. Should piss anybody else off also if they actually care about where the hell their money goes. But all lenses are electrical circuits. Well, what the hell does that mean? Well, that sounds like, that's what people accuse Yannick of when he actually wrote a couple of articles recently. But I mean, I've been hearing that for years. I mean, I've told people that, and you're like, oh, what the hell are you talking about? It's all about optics and transmission and coma and MTF charts and IQ and chromatic aberration and lateral transmission. No, it's not. That's the ultimate goal, but the nature of how these lenses are designed, that's not the... Why the hell do you think Nikon and Canon and all the Zeiss, they've all got their secret recipes, and they'll talk about ED glass, and you know, there's other sorts of elements. There's extra low dispersion, there's low dispersion, special low dispersion, extraordinary low dispersion, ELD, which used to be thorium oxide. Radioactive, this is a radioactive lens too, by the way. This old AI 200mm f4. And ULD, ultra low dispersion lenses, but they're doped. with. Doped means when they're actually casting the glass, they actually add some rare earth, lanthanines, and other elements to them, oxides, like calcium fluoride, titanium dioxide, zirconium dioxide, niobium oxide. Used to use which is what's in this one, radioactive thorium oxide. Now they use Nikon's famous ED glass has a high content, a very high content of lanthanum oxide. It's an ingredient used in piezoelectric and thermoelectric materials. Lanthanum is extremely electropositive, and basically what this does is it changes the ultimate chromatic aberration recorrection of far and near spectrum of light, which passes through the lenses. Now the optics are one thing, but these lenses have these doped chemical additives in them, and each company has their own recipe, and they got to work out a lot of crap. I mean, it's like doing a Rubik's Cube blindfolded. It's not just about optics and plugging crap into a software application, because a lot of it, there's a million ways you can build, literally, about a million different ways you can build a 200mm f4 or any other friggin' lens. Well, I can make this achromatic, I can add this lens, I could change the refractive index of this lens, I can add an aspherical here, I could add the aspherical back here, but if I add the aspherical back here, I have to turn this into an ED element, but if I turn this into an ED element, I got to add a flint element back here, but if I add an achromatic doublet up here, I have to change this to an ED element, but I change that and I add this, I got to change it. Whatever you change, you're going to fuck up something else. And so lens designers have, and there are very few of them, have a very, very hard time doing this. So it's not strictly about the optics and plugging crap in, which you can do. It's like, well, if I add this with this level of refractive index, then I have to change this. That would be very simple. So designing lenses would be very simple. But that's not the end of it. Each lens has to have its own characteristic that the manufacturer desires. And a lens is an electrical circuit. Back in the days when it used pure optical glass, which hasn't been done for ages. Okay, it's just glass, okay? I get the right refractive index, boom, 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 boom. Of course, they didn't have applications back then, but they could still work out what the refractive indexes were, and boom, 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 he built the lens. They weren't that great, and they flared really bad, and they had no anti-reflective coating. But anti-reflective coating has nothing to do with the electrical transmission and chromatic aberration of the lens. It only has to do with the actual visible permittivity of the actual circuit of light, meaning that it has extremely low reflective properties, anti-reflective coating, or they call it multi-coating. It's got a lot of different names, but it's all the same shit. But every lens has been made now for the past 50 plus years, some all the way back 70 years. Is an electrical circuit, okay? This is an irrefutable effing fact. And these people say, oh, well, that's all BS and crap when what's-his-face wrote the article. This is crap. Crap! Lenses are electrical circuits. Light is a coaxial circuit, okay? The refractivity of near-end spectrum and far-end spectrum is light. Of light is different. That's why higher frequency light is that which will scald your ass. I mean, it will burn you. You start getting up towards X-ray. Of course, that's not visible spectrum. The higher the frequency, the more dangerous it is. It has a higher dielectric capacitance. That's because glass is a capacitor. Okay? Silicon dioxide. Gee, I thought they made semiconductor circuits out of that crap. Yeah! It's a semiconductor. Light is a circuit. So it is not merely about refractive indexes or aspherical elements or achromatic doublets or flint elements. Every lens manufacturer on Earth, and this is 100% effing refutable, designs these lenses to have special dielectric permittivity and magnetic permeability qualities and characteristics that add to the character of the lens. By doping the glass, doping, okay, you understand what that means, doping, by adding lanthanum oxide, niobium, thorium, and everyone's got their own little secret recipe, and Nikon or Zeiss or Canon, Leica, nobody is going to tell you what the F is in their lenses, or how they dope it, or what additives they add, and what percentage, at what time of manufacture. That is the secret crap, the secret sauce of every lens manufacturer. Now, anybody could plug in, you can download it yourself, an application. If I want to design a 35mm lens, all I have to do is plug in this. It says I got to build a lens this way, this way. This lens has this refractive index, and I got to have an achromatic doublet here, boom, 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 boom. Anybody could download that and build a lens. Nikon is paying these guys some serious bucks, the very small group of hardcore dweebs that build this stuff. They're paying them serious bucks, not because an application could do the same thing, which it can, but it can't build the lens. Because this ED doped glass has to have special dielectric and magnetic permeability, dielectric permittivity, and magnetic permeability characteristics, and each one is unique to Zeiss. That's why each lens manufacturer has their own unique characteristics. Zeiss has their own look. The Sigma Fart lenses have their own look. These old lenses have their own look. They design them because they know how to not only plug in the numbers of the achromatic elements, and the ED glass, and the doublets, and the refractive indexes of what sort of glass is in there, but also the doping of the glass such that the permittivity and dielectric permeability is such that it has a certain characteristic, and designing that is extremely hard. Every lens is an electrical circuit. Light is electricity. Solar panels. Silicon dioxide, glass. Semiconductor. Oh, so it's not just about plugging in numbers to create a lens. They dope certain elements. Yes, they add in ED glass. These are the doped elements, but they also add in aspherical element. All of that can be plugged in. Aspherical elements in the doublets, and the refractive indexes of certain lenses, but they have to know how to build them to have special character. This is what burns me. This is what burns my ass. Okay, what do you think light is? You think it's just glass and optics and refractive indexes and AR coatings and aspherical elements? No, it's not. It is not. This is the same reason why Canon uses fluoride elements, and also the same reason why NASA told Canon to shove it up their fannies, because the fluoride elements are very fragile, and extreme vibration heading up to the International Space Station. The fluoride elements, since they're so fragile, had a tendency to explode. That's why NASA uses Nikon. Of course, who the hell is going into space? Who gives a damn about that, right? Well, unless you drop your Canon lens, in which case you damn well better have insurance on it, because if it's got, Nikon's already starting to use fluoride elements now too, but yeah, if you dropped your large Canon lens with fluoride elements in it, then watch out, because you're going to have to make an insurance claim on it, assuming that you have insurance. But this is really important. I mean, do you need to know any of this crap to take pictures? Well, hell no, of course you don't. But nobody else is talking about this, and they should be. Because, you know, a lot of you guys are out there sniffing. This is the radioactive lens, too, with thorium oxide doping in one of the elements, and it's radioactive. I assure you, it is. That's that brownish yellowish tint you actually see in the lenses of some of the old ones. That's thorium oxide radioactive doping, which changes the dielectric permittivity of the lens, which helps in chromatic aberration. But now they use lanthanum oxide. That's Nikon's claim to fame, is that they use lanthanum oxide. They don't just use that, but they won't tell you what else they use, because that's a trade secret. You're not going to find that on Nikon's website anywhere, or on Zeiss's website what they use, or Sigma, or anybody else, or Tamron, because that's a trade secret. Anyway, we're going to do ongoing video series on these, talking about resolution versus micro contrast, blah, 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 blah. Anyway, thanks for watching. If you like this video and not a buck or two, go tell me to jump off a cliff, whatever makes you most happy. Another video from the Angry Photographer. Okay? Bye.